Welcome to the lesson on the reactivity series and the reactions of metals. So first of all, we need to look at how metals react with water or with acid. So when a metal reacts with water, just like group 1 metals that we've covered previously, they will form a metal hydroxide plus hydrogen. Now, the only condition really is that the metal has to be more reactive than hydrogen, otherwise this reaction does not take place. For example, copper is less reactive than hydrogen, so copper does not react with water. That's why it is used in pipes. Now, obviously, there's a big difference in the way metals react depending on their reactivity. So if you think of a metal, you don't think of it as reacting with water at room temperature, okay? Unless it's like in group 1, some of the group 2 metals. So in order to test its reactivity, you may need to heat up the water, or you may need to use an acid. If you use an acid, then the metal is more likely to react. And obviously, if you heat up the acid, it's even more likely to react. So you need to be aware of what happens when a metal reacts with an acid as well. So a metal plus an acid will make a salt plus hydrogen. The salt will be dependent on the acid used. Now here, there's a whole range of acids. You mainly need to focus on hydrochloric and sulfuric. But you should be aware of, I would say, all of them. Reason being is that ethanoic acid is something you'll meet in the carboxylic acids topic. So why not learn now that it can form a salt? Okay, so hydrochloric acid makes chloride salts with the Cl minus. The sulfuric acid, H2SO4, make sure you know all of this, forms sulfate salts because it contains the oxygen, and it's SO4 2 minus. Nitric acid forms nitrates with NO3 minus. Now, phosphoric acid is unlikely to come up, but it forms a PO4 3 minus ion and forms phosphate salts. So, for example, magnesium chloride, magnesium sulfate, magnesium nitrate, magnesium phosphate, magnesium ethanoate. So ethanoic acid, this green H gets replaced by the metal, and you form the ethanoate salt because the charge is -1. So obviously, if it's a group 2 metal, you'll need 2 of this. So you have to put brackets in a 2. Example being, so if it's a group 1 metal, you would have this scenario here. If it's a group 2 metal, then you would need 2 of these -1s to say balance the Mg2+. So that'll be magnesium ethanoate. But as I said, primarily, especially in Edexcel, this part of the syllabus, you would focus on these 2. But you should be aware of all of them in general for the whole chemistry course. Now, in summary, these metals will react differently depending on what you react them with. So I have 2 versions of these notes. Perhaps these are more detailed. So if we look at this table, we have reactions with air, so with oxygen, where they make a metal oxide, reaction with water, and reaction with acid. So have a look at how these observations are based. The first 3 metals, with potassium being the most reactive, are very violent. Okay. As you go to the less reactive ones, calcium, again, they burn easily, these 2. Magnesium doesn't really react with cold water, it reacts with steam. And that's a separate reaction. That reaction is the following: magnesium plus steam, and it actually forms, instead of a metal hydroxide, it forms a metal oxide. So you get magnesium oxide plus hydrogen. So it is a slightly different one, okay? Notice though, if you don't react with, if you're quite fast with cold water, you're very fast with acid. So remember, acid is the most likely to react with the metal. As I said, copper doesn't react, so it's no reaction because it's below hydrogen. And zinc and iron are just above hydrogen, so you can see they're quite slow. So by looking at observations, you can put metals in order of reactivity, and sometimes in exam questions, they will ask you to deduce the order of the reactivity from the reactions. Obviously, you should know the reactivity series by heart as well. So that would be a check for you. But if they put a metal that is an unknown one, or it's not, or it's a made up one, like just a letter, then obviously you need to be able to adjust and put it in the right position. So that's what this syllabus point says here. Understand how they can be based on their reactions of displacement. I'm going to go over this into a bit more depth, and then I will come back to show you this. So I want to cover in a bit more depth here. Okay, these are the same table. I mean, both notes will be attached for you. And here are some equations you can practice. Again, the answers to these will be in the notes. So potassium hydroxide plus hydrogen, no reaction. Magnesium phosphate plus hydrogen, calcium hydroxide plus hydrogen, and aluminium sulfate plus hydrogen. You should practice doing them with state symbols and with chemical equations. So I shall do one for you. Al plus H2SO4. So that's metal plus acid. You should make salt plus water. Now the salt is Al. Now Al is 3 plus and SO4 is 2 minus. So you cross them over, the charges. So you get Al2, SO4 3. Don't know why I put a bracket around the Al. That was unnecessary. Make it look neater for you. You only put the brackets if it's 2 capital letters, polyatomic ion. It will be hydrogen. So gas, metal forms a soluble salt. Now acids are always aqueous because they have to be dissolved in water to release their hydrogen ions, and aluminium is a solid. Observation-wise, you would observe fizzing and the metal disappearing. Heat is also generated. Now, let's look at displacement reactions. So we look at this one in a bit more depth. So firstly, what is a displacement reaction? It's when a more reactive metal displaces a less reactive metal from its compound. The same way a more reactive halogen will displace a less reactive halogen in the group 7 topic. A quick reminder, oxidation is gain of oxygen, but it's also the loss of electrons. And reduction is the removal of oxygen or the gain of electrons. So we're going to use this example to go in depth on the observations and all the equations about it. So I'm going to connect my pad here and write this out for you. Okay. I recommend writing out this equation. So I'll go through all the different stages of what a redox reaction is. I've done it once before, but this is the proper lesson on it, where I'll explain it in detail. I did it with group 7 as well. So magnesium plus copper sulfate. First thing to note is that magnesium is above copper, so it is more reactive. So a reaction will occur. So what we have here is Mg plus CuSO4 goes to, now you just swap the positions. So it will form MgSO4 plus Cu. This is a solid that's being put into a solution. The blue solution here is the copper sulfate, and that's the solid that you've put in. Over time, you can see the solid actually comes out as a red-brown copper. This is the red-brown observation. And the MgSO4 is aqueous. So the blue color will fade because the copper sulfate is the blue one. This is blue. This is colorless. So over time, the blue color fades and goes. And this is a red-brown deposit. For all the other metals, you can say shiny, but silvery solids. For copper, it's a red-brown solid. So that's called a chemical equation. And the magnesium has displaced the copper from its compound because it is more reactive. That's how you'd explain it in words. Now, for the ionic equation, it goes as follows. All the elements stay as they are, or anything covalent stays. But all these aqueous ones, the salts, they split into ions in between the water molecules. So the copper, you're supposed to know it's 2 plus. SO4 is 2 minus. Mg is in group 2, so it's 2 plus. SO4 is still 2 minus. And the copper stays as an element. Now what you'll notice is that the SO4 2 minus is the same on both sides. So it cancels. It is called a spectator ion. It spectates but doesn't actually take part in the reaction. Where's the black color gone? Okay, so then the final answer is Mg, solid, plus Cu2 plus aqueous goes to Mg2 plus aqueous plus copper. Now you have to know which one is oxidized, which one is reduced. So it goes as follows. The one that loses electrons is oxidized and becomes positive because you've lost your negativity. So this is oxidation. Loss of electrons. Whereas this one goes from positive to neutral. So it must have got some bad news, something negative. So this is called reduction, which is the gain of electrons. So we call this a redox reaction. Red stands for reduction, ox stands for oxidation. So a redox reaction is defined as having simultaneous oxidation and reduction in the same reaction. And the Mg was oxidized. So Mg, and we've got Cu2 plus. In brackets, copper ion. Don't say copper. It is the copper ion that is reduced. So I'll put that in actual words. Cu2 plus is reduced. So it is an oxidizing agent. And Mg is oxidized and is a reducing agent. So it's a bit like opposites. People can find this slightly difficult, but just think, if I'm going to be a reducing agent, okay, I'm going to reduce you. Now, reduction is gain of electrons. So I'm going to give you electrons. Here you go, here you go, here you go. I gave mine away. So I myself lost my electrons, so I got oxidized. In a similar fashion, Cu2 plus, if I'm an oxidizing agent, I'm going to make you lose your electrons. So I'm coming along and I'm oxidizing you. I'm removing your electrons and taking them to myself, which means I'm gaining them, which means I'm reduced. So they're a little bit like opposites, okay? So in an exam, if you're asked to identify the oxidizing agent, you would say the whole copper sulfate. And the reducing agent would be the magnesium. But if they give you an ionic equation and ask you for which species is reduced, you would say the copper ion is reduced. Make sure it's the ion. Okay, people sometimes put the copper, which is just wrong. That is pretty much all of it. It's quite high level stuff, the redox part. The displacement part is low level, but the redox part is high level. So I've saved this into the notes, and now we're going to move on. Okay, so we're not yet at metal extraction, so we'll minimize this for now. We're going to just recap this using these two processes because you need to know about salts and metal oxides being displaced. So let's look at this. This is a famous reaction called a thermit reaction or thermite reaction. So the aluminium will react with iron oxide. No, they're both solids, so they require a spark of heat from a match, this reaction does, because otherwise two solids just don't react. What happens is aluminium is higher than iron, so it will displace the iron from its oxide compound, and it will form aluminium oxide and iron will come out. This is very useful because they use it for railway tracks. The reaction itself generates a lot of heat, And so the iron that comes out can be molten and can be used to form the railway tracks. The reaction itself is very vigorous, just like I said. So it actually produce temperatures above 2000, which is actually higher than both of these melting points. So that's very useful for making the railway tracks. So this was an example of a metal oxide being displaced. And you should also know, just like I did with the magnesium and the copper sulfate, you can use zinc. So this is the same thing. It says iron cannot displace magnesium because iron is less reactive than magnesium. So the ionic equation for this would be Zn plus Cu2 plus goes to Zn2 plus Cu. You just ignore the SO4s and turn these into ions. So it's quite a useful trick you can use. You don't have to derive it like I did. You can just write Zn plus, ignore that, keep that. Ignore, keep. Done. So basically there should be like a reflection on the opposite side where this had no charge and now it has a charge. And that's it. Okay, so next I'm going to show you the reactivity series. So this is the reactivity series that you need to know. And then after that, we have to cover the rusting of iron. And we've pretty much done the topic. So we can do it. Let's have a look at the reactivity series. Potassium, sodium, lithium, calcium, magnesium, aluminium, zinc, iron, copper, silver, gold. You need to learn this reactivity series. However, I would stress that you should learn the reactivity series with hydrogen and carbon in it. So I'm going to bring up my reactivity series in the notes I attach. And it is here. Potassium, sodium, lithium, calcium, magnesium, aluminium, carbon, which is not a metal, but it falls there. We can use this for the extraction of metals later on. Zinc, iron, hydrogen, and then as you can see, only copper, silver, gold, and platinum will be less reactive. Okay, everything else will be more reactive. Okay, so that's the reactivity series. There's different ways you can try and remember it. There's loads of different mnemonics. You should make up your own one that works. I mean, my one from school was PSLC Mac Zintel. He can make some gold plates. PSLC Mac Zintel. He can make some gold plates. That's how I remember my chemistry teacher teaching it many years ago. So it is PSC, or we can add the L, PSLC, Mac, where the C is the carbon, Zintel. Now here's where nickel and tin come in, and lead. He can make some gold plates. This is like your complete list. PS, potassium, sodium, lithium, calcium, magnesium, aluminium, carbon, zinc, iron, nickel, tin, lead, hydrogen, copper, manganese, silver, gold, platinum. Now that is obviously more than you need to know. So, but that's the way I learned it. And it's useful because that will give you kind of nickel and tin and lead, which can come up in exam questions. So that is the list. Next, we need to look at the rusting of iron. And we were going to do that, but we'll do it in a separate lesson so that the lesson doesn't become too long. So reactivity series done, and how to do displacement reactions. Next lesson, rusting of iron. See you then.